So NVIDIA just dropped something that could be a real game changer for self-driving cars. It's a new AI model called Alpamayo-R1, and the goal here is, well, it's incredibly ambitious. They want to create a car that doesn't just see the road, but actually thinks and reasons about it, kind of like we do. Let's get right into it.
And you know, it's a question we all ask. We've been hearing about the promise of autonomous vehicles for years, right? But that true level 4 autonomy, where the car handles pretty much everything, still feels like it's just over the horizon. So what's the real holdup?
Well, it really boils down to this one big problem: long-tail scenarios. Now, what are those? They're the weird, unpredictable, once-in-a-million-miles kind of situations. Think, a couch falling off a truck ahead of you, or a flock of birds suddenly landing on the road. Your standard AI is great at the 99% of normal driving, but in these weird edge cases, they can become brittle. They just break.
See, the problem isn't that the cars can't see what's happening. It's that they don't truly understand the why behind their own decisions. This is what the researchers are calling the reasoning gap. It's the huge difference between a car just narrating a scene versus a car making a smart decision based on actual cause and effect.
And this slide right here, it just lays out the problem perfectly. On one side, you have current AIs giving these super vague outputs like "be cautious," or useless observations like "sunny weather." Even worse, they can get causally confused, talking about things that haven't even happened. What we want, the goal, is what's on the right: reasoning that is causally grounded, linking specific evidence, like that oncoming car, directly to a decision.
So this is the big question, right? How does NVIDIA plan to bridge this reasoning gap? Well, their answer is Alpamayo-R1, and it's a whole new approach built on what they call 3 core pillars. This is how they plan to teach a car how to actually think.
And here they are, the 3 pillars of the whole system. First up, you've got causal data, a totally new way of teaching the AI. Then there's a modular architecture, built to be super efficient. And finally, advanced training, which is the secret sauce for aligning the AI's words with its actions. Let's break each one down.
Okay, so pillar 1. This is all about the data. And honestly, this might be the most important part. NVIDIA built a completely new data set they call chain of causation, or COC. And the process is, wow, it's incredibly detailed. They don't just use any driving footage. They find specific clips where a tough decision is required. They then pinpoint the exact frame where that decision is made. And then, and this is key, human annotators label the specific causes that led to the final driving action.
And what you get from all that hard work is just incredibly high-quality data. This is the secret sauce. Instead of the AI learning to say "be careful," it learns a clear, structured reason for its actions. Something like, "I'm aborting the nudge to avoid hitting that car, and I'm stopping for the car that's right in front of me." It's specific, it's causal, and it's something you can actually trust.
All right, pillar 2. Think of this as the engine under the hood. It's a modular architecture designed from the ground up to be fast. It uses a really powerful model as its brain, one that already has a good dose of physical common sense. But what's really wild is the efficiency. It can compress the visual information it's seeing by up to 20 times. That is huge for real-time performance. It all comes together to produce driving commands that are fast, smooth, and stable.
Okay, so you've got the special data, you've got the powerful architecture, but how do you actually teach this thing to think? That brings us to pillar 3, the training process itself. This isn't just about showing the AI a bunch of videos. It's a sophisticated, multi-stage process designed to perfectly align what the car says with what the car does.
It's not one big training session. Nope, it's a careful 3-stage process. In stage 1, the model just learns the basics, how to drive normally. Then in stage 2, they use that special COC dataset to teach it how to explain its reasoning. But here's the thing. For something as critical as a car, just teaching it to explain itself isn't enough. There's a hidden danger.
Because here's the catch. If you only show the model examples, it can get really good at talking the talk without walking the walk. The AI might create a perfectly logical-sounding reason for an action that doesn't actually match what it's doing on the road. It's a problem called hallucination, and in a car, it's totally unacceptable.
And this is where stage 3 gets really, really smart. They use reinforcement learning to fine-tune the model. Basically, the AI gets feedback or a reward based on a 3-part report card. First, was your reasoning high quality? Second, did your actions actually match what you said you were going to do? And third, was the drive itself safe and smooth? This constant feedback loop forces the AI to make its thinking and its driving one and the same.
Okay, so that's the whole setup. A new dataset, a slick new architecture, a super smart training method. But let's get to the real question, the one you're probably asking right now. Does it actually work? What do the results look like?
Well, the numbers speak for themselves, and they are seriously impressive. In simulations, Alpamayo-R1 slashed the rate of driving off the road by 35%. That's not a small tweak. That is a massive leap forward in a super important safety metric.
And remember those bizarre long-tail scenarios we talked about? The ones that are the whole reason this is so hard? The model showed a 12% jump in its planning accuracy specifically in those tricky situations. This proves the reasoning is making a difference exactly where it's needed the most.
And here's the kicker. It does all this thinking fast. In real-world road tests, the time from seeing something to acting on it was just 99 milliseconds. That is incredibly quick, well within the safety margins needed for real driving.
Look, if you want to see the difference in black and white, this chart says it all. You can see AR1, in blue, just performing way better than the baseline model. A significant drop in going off-road and fewer scary close calls with other objects. The data is clear.
But simulations are one thing. The real test is on the actual road. And here it is. This isn't a simulation. This is Alpamayo-R1 in a real car driving through complex city streets in real time and generating these clear causal explanations for every move it makes. That's the proof right there.
So, when you put it all together, what are we looking at? What's the big picture here? Well, this whole approach feels like a really significant step forward. It's not just another small improvement. It's a new path, a credible way to finally reach that goal of robust, level 4 autonomy.
So to recap, the magic here really comes from those 3 core ideas we walked through, starting with causal data to teach the why, using a fast modular architecture that can keep up, and applying that advanced training to make sure the AI's reasoning is always safe, sound, and consistent with its actions.
And this, for me, is maybe one of the coolest parts. NVIDIA is planning to release some of the Alpamayo-R1 models and even a part of that special Coke dataset out to the public research community. That is a huge deal for pushing the entire field forward way faster.
So at the end of the day, the big takeaway is this. The finish line for self-driving cars might not be about just cramming in more data or building ever bigger models. It might be about teaching them a skill they've never had before, genuine reasoning. By teaching a car not just to act, but to think, Alpamayo-R1 might just be one of the most important steps yet on the road to our autonomous future.